Hi, I'm Andy and this is question 2 on the AQA Decision 1 paper from June 2016. For more questions on this exam paper, click the eye in the top right corner. In question 2A, we're asked to use a shuttle sort to rearrange into alphabetical order the following names: Rob, Eve, Meg, Ian and Zavi. So our initial list is REMIX, and in a shuttle sort we compare the first two numbers. So we can draw a line here and we're going to compare R and E. Now R and E alphabetically are in the wrong order, so they're going to swap. So this is going to become E and this is going to become R. Everything else will stay the same. In the second pass, we begin by comparing the second and third letters. So R and M are in the wrong order, so R will definitely move to here. But before we write M down here, we should see if it's going to move again. In this case it won't, because E comes first alphabetically. So we should end up with E, M, R. Everything else stays the same, and that's the end of pass 2. In the third pass, we first compare the third and fourth elements. So I is going to swap with R, so R will move here. But we also have to see, will I keep going? And I comes before M, so it will move past there as well. And so I will end up here. So what happens in a shuttle sort is the thing that you start with at the end of the list here will move to its respective place in the list, and everything that's bigger than it will move past it. For the final pass, we start with our X, and X doesn't move past anything, so we get the same list again. It is important to have this final pass though, because that demonstrates that you have compared the last item. In part B, we're told a list of 10 numbers is sorted into ascending order using shuttle sort. How many passes are needed? Well, if you look at the example we've got here, which involved 5 items, we needed to do 4 passes in order to get them in order. And with shuttle sort, unlike some of the other sorting algorithms, there's no case in which you stop the sort early. Like with bubble sort, you might be done after a couple of passes, but with shuttle sort, you always need to do all of the passes. And the number of passes is always going to be 1 less than the number of items, because for the first pass you compare 2 of the items, and then each pass after that compares 1 extra item. So B part 1, if we got a shuttle sort of 10 items, you would need 9 passes. In part 2 it says give the maximum number of comparisons needed on the 6th pass. Well, if we look at our example in the 4th pass here, imagine that this was an A. We would have had to move it 1, 2, 3, 4 times. And it turns out that in a shuttle sort, the maximum number of swaps is always going to be equal to the pass number that you are on. So for example, if we went back to pass 1 here, the maximum number of swaps here was 1. Pass 2, when we were comparing this number, the maximum would have been 2. And so the maximum number on pass 6 will always be 6 swaps. It doesn't even matter how many items are in the list, that will always be the case. Finally, for part 3, it says given the list is initially in descending order, find the total number of swaps needed. Well, if the list is in descending order, each time you start with an item, you're always going to move it right to the end of the list, because it will always be smaller than everything that's come before it. And we already know that on whatever pass number it is, that is the number of swaps that we would need in this case. So on the first pass with 10 numbers, we would have to do 1 swap, and then on the second pass 2, all the way up until the 9th pass, in which case we would need 9 swaps. And if we did 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, we would get 45. There is actually a formula which comes up a lot in the decision module that does this calculation for you, and that is that the answer would have been a half multiplied by n times n minus 1, where n is the number of items. So in this case, this will be a half of 10 times 9, which, as we would expect, gives us 45. This formula is a much more efficient way of doing it, particularly the larger the number of items gets.